Every single second, your computer is doing billions, literally billions of calculations. But have you ever stopped to wonder how? How does it actually work? Well, today we're pulling back the curtain on the brain behind the whole operation, the CPU. Let's dive right in.
Yeah, how does your computer think? It's a great question, right? Because it really is at the heart of everything we do. Every click you make, every key you press, every video you watch, it really feels like your computer is thinking. So how does it go from your command to, actual action? The secret, it turns out, is a tiny little marvel made of silicon.
And that marvel is this right here, the CPU. It stands for Central Processing Unit. And honestly, calling it the brain of the operation isn't an exaggeration at all. Its whole job, its entire mission, is to take in instructions, crunch all the numbers, and basically direct traffic for all the data flowing through your computer.
Just think about it for a second. When you open an app, yep, that's an instruction for the CPU. Saving a file, that's another one. The CPU is this tireless engine that just takes every single one of your requests and makes it happen. It's the powerhouse behind literally everything you do on your device.
So the big question is, how on earth does it manage this incredible workload? Well, it all boils down to a really simple, endlessly repeating cycle. And this, right here, this is the aha moment. This is how a CPU really gets work done.
And here it is. That cycle in its simplest form. Just 3 steps. Fetch, decode, execute. That's it. Seriously, every single thing your computer does, from the most complex game to the simplest calculation, is just the CPU repeating these 3 steps over and over and over again at an unbelievable speed. So let's break them down.
Okay, first up is fetch. This is where the CPU reaches out to your computer's memory. That's the RAM, and it just grabs the very next instruction in line. It pulls that instruction inside itself and pops it into the super fast, temporary little holding spot called a register. Think of it like grabbing the next item off your to-do list. All right, step 2, decode. So now the instruction is inside the CPU. This is where a part called the control unit steps in. It's basically the interpreter. Its whole job is to look at that instruction and figure out what it means. Is it a math problem? Do we need to move some data from one place to another? The control unit figures it all out and gets all the right parts ready for the job.
And that brings us to the final step, execute. The control unit passes the job off to another piece of the CPU, something called the Arithmetic Logic Unit, or ALU for short. The ALU, now this is the powerhouse. This is the part that does the actual work. It does the math, it makes the comparisons, it carries out the command, and as soon as it's done, boom, the whole cycle starts right over again with the very next instruction.
So we've already mentioned a couple of these key parts, right? The control unit, the ALU. So let's take a second to properly introduce the whole internal team that makes this magic happen. You can really think of them as a highly specialized crew, where every single member has a critical role to play.
Okay, so let's meet the team. You've got the control unit, that's the manager, directing all the traffic. Then there's the ALU, the master calculator that does all the heavy lifting. The registers? Think of them as a tiny super-fast scratch pad, just for the immediate task. And finally, the cache. The cache is kind of like a high-speed pantry right next to the workspace, holding all the frequently used data, so the CPU doesn't have to go all the way to the main memory, the RAM, every single time.
Okay, I know. All these technical terms. ALU, registers, cache, it can be a lot to keep straight. So, you know what? Let's use a simple analogy to tie it all together. This should make it way easier to picture. Just imagine your CPU is a master chef in a kitchen.
Okay, so let's map this out. In our kitchen, the CPU, that's the chef. A program you're running, that's the recipe book. The RAM is the big fridge in the back, holding all the ingredients. So fetch is just the chef getting ingredients from the fridge. Decode is the chef reading the recipe to see what to do next. And execute, well, that's the actual cooking. And the registers we mentioned, that's the countertop, the immediate workspace right in front of the chef. See? When you put it that way, it all kind of clicks.
So we've got the process down, right? Fetch, decode, execute. But what makes all of this so incredibly powerful is the speed. We've talked about the cycle, but the truly mind-boggling part is just how fast it all happens.
Just look at that number. It's huge. When you see a CPU advertised with a speed like, say, 3 gigahertz, what that actually means is that it can run that entire fetch, decode, execute cycle 3 billion times every single second. That's not just fast, it's almost impossible to wrap your head around.
And if that wasn't enough, to make things even faster, Modern CPUs have multiple cores. So if we stick with our chef analogy, this is like having several chefs in the same kitchen. Each one can be working on a different recipe, or maybe they're all working on different parts of the same really complex recipe, all at the exact same time. This is exactly how your computer can stream music, run a game, and have, a dozen browser tabs open all at once without breaking a sweat.
So look, if you take away just one thing from all of this, let it be this. Everything your computer does, everything, boils down to this one simple loop. Fetch an instruction, decode what it means, execute the task, and then repeat. Billions of times, every second. That's it. That's the engine that powers our entire modern world.
It's amazing, right? This incredibly simple cycle is the foundation for everything from a basic calculator all the way up to the most complex AI. It really makes you wonder, if today's CPU is the brain, what will tomorrow's computers dream of?